In October 2017, something passed through our solar system. It came from nowhere we could identify. It belonged to no known star, and before scientists could fully understand what they were looking at, it was gone. But that wasn't the mystery. The mystery was how it moved. After swinging around the sun, the object began to accelerate, for no visible reason. No tail, no gas, no dust. No telescope on Earth could explain where the thrust was coming from. This was the first interstellar object ever recorded in human history, and it wasn't behaving like a rock. If there's a natural explanation, we've discovered an entirely new class of objects in the universe. If there isn't, the question becomes something else entirely. By the end of this, you'll understand why some of the most careful scientific minds on the planet still haven't closed this case, and why one of Harvard's leading astrophysicists put his reputation on the line for a single hypothesis. October 19th, 2017. The Pan-STARRS Observatory, Hawaii. A routine sky survey picks up a moving object. At first, nothing unusual. Another asteroid. But when astronomers calculated its trajectory, something didn't add up. The velocity was too high, far too high for any object that belonged to our solar system. It had come from interstellar space, from somewhere between the stars. For the first time in the history of observation, they named it Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. The name turned out to be more prophetic than anyone expected. As telescopes around the world locked onto it, something strange began to happen. By the time astronomers discovered Oumuamua, it was already on its way out of the inner solar system. It had passed Earth at a distance of roughly 15 million miles, more than 60 times farther than the Moon. By cosmic standards, that was practically a close encounter, but even then, it was moving far too fast for humanity to send anything after it. Relative to the Sun, its speed exceeded 190,000 miles per hour. It crossed Earth's orbit, swung around the Sun, and continued its journey back into interstellar space. Today, Oumuamua is far beyond the orbit of Neptune, growing more distant with every passing second. It is heading toward the constellation Pegasus, disappearing deeper into the darkness between the stars. Even the most powerful telescopes can no longer see it. For humanity, the object has effectively vanished forever. The brightness of the object was changing, dramatically, cyclically, by a factor of 10. For an asteroid, that's almost impossible. To produce that kind of variation, the object would need an extremely unusual shape. Computer models produced two possibilities. Either it was shaped like a cigar, long and narrow with proportions up to 10:1, or it was shaped like a flat disk, impossibly thin for a natural object. Neither had ever been seen before among known asteroids. Nature rarely builds things like that. But that was only the beginning, because when scientists went back to the trajectory data, they found something they couldn't explain. After Oumuamua rounded the Sun and began moving away, gravity should have been slowing it down. Instead, it sped up. Slightly, but enough to measure, enough to matter. Comets can do this. Ice sublimating in sunlight creates a kind of natural jet propulsion, but the telescopes detected no water molecules, no dust, no outgassing of any kind. Nothing. The acceleration was real. The engine was invisible. In 2018, astrophysicist Avi Loeb, one of the most cited scientists at Harvard, reviewed every piece of data and proposed something that divided the scientific world. What if Oumuamua was a light sail, a thin structure pushed by the pressure of sunlight itself? No engine, no fuel, just photons pressing against an extremely large, extremely thin surface. The model fit the acceleration perfectly. It explained the absence of a tail. His colleagues were not impressed. Most called it speculation, but Loeb pointed to something they couldn't refute. No other theory explained all the observations at the same time. And this is where the story takes an unexpected turn, because Loeb wasn't talking about a spaceship. He was talking about wreckage, a technological artifact long abandoned, a probe that lost contact millions of years ago, a fragment of some other civilization's history, drifting silently through interstellar space. That's a very different question, because wreckage doesn't require anyone to still be alive. It only requires that someone somewhere once was. Where does science stand today? Most researchers lean toward natural explanations. One theory, an unusual comet carrying material that sublimated without leaving a visible trace. Another, an object rich in nitrogen or hydrogen, substances that evaporate almost invisibly. A third, an entirely new class of interstellar body that we simply don't have a name for yet. Each theory solves one problem and leaves another open. None of them explains everything at once. But here's what troubles astronomers most. If Oumuamua was a random object that drifted into our solar system from interstellar space, then statistically, there should be trillions of such objects moving through the galaxy right now. Hundreds of them may be passing through our solar system at this very moment. We just can't see them. And if even one of them turned out to be something other than natural, we would almost certainly never know, because we have no spacecraft fast enough to catch it. Oumuamua came. It spent a few weeks near us, and then it left at 90,000 kilometers per hour, back into the dark it came from. We didn't get to study it. We barely got to see it. But it left something behind. Not an answer, a question. The universe is vast. It contains hundreds of billions of stars, and it is constantly sending us things. Fragments of other worlds, remnants of other histories, objects we don't yet have the language to describe. The question was never whether we are alone. The question is whether we're paying close enough attention when something passes by.